Last time on Big Data and Brews, Stefan and Antonio talked about what brought Antonio to California.
When my friend who lives in Sunnyvale took me around the Silicon Valley the first time, he showed me, this is Apple, this is HP. And they told me, this is like bringing a priest to the Vatican. This is the place to be.
They talked about Antonio's work on the earliest versions of Hadoop at QuantCast.
It was breeding ground. It wasn't like a black box, you don't touch it. It's 0.16, okay? So we can touch everything. We can even make it better.
And his current work with Revolution Analytics.
We have an open source project and we are combining R and Hadoop.
And now, here's some more Big Data and Brews.
All right, welcome back to Big Data and Brews. So let's talk about your open source project. So the way I would think about this is I'm just writing R code and say, now execute the R code distributed on Hadoop cluster. Is that the way to think about it? Or can you explain more how the whole overall user interface, the user interaction from my side as an R day-to-day user looks like?
So it's, I wish it were that simple, but it's not so simple. So there's the project has several components, so one is RHbase interfaces with HBase, RHDFS interfaces with HDFS. So for RHDFS, the comments are really similar to what you expect on a regular file system. So you're just moving a file, move a file, and you just probably prefix with HDFS, but that's it.
But it's in R basically, so it's I can use the R.
Exactly. You are at the prompt, at the R interpreter, or you can write scripts or modules, whatever your level of development in R is. With HBase, you start having a unique database model that people are not used to. So people, if you're used to, RODBC, the SQL interface for R, then they think, oh, it's another database. Well, they're going to find out that these days there isn't one database, there's many, and each one has different capabilities. So the RHbase interface is pretty much modeled on top of an interface. You can get a range of keys, you can create a table, you can, all the things you can do in HBase. You can do a join, it's not built in. So it doesn't have a big layer of abstraction on top of it that adds secondary indices or other stuff that HBase doesn't have, but somebody could build conceivably. And when you get to one package I work on in particular is RMR2, that's interfaces with MapReduce. You have to organize your computation around MapReduce.
Okay.
So that's a big surprise for people that like R for a number of reasons, in particular because it has some 5,000 packages, many of which implement the latest and greatest statistical methods, and they hope they can just load the GLM and say, okay, super magic powder here, and now it runs on Hadoop. And unfortunately, that doesn't help. It doesn't happen. You can use all these packages inside the MapReduce functions. That's great.
But you still have to write MapReduce functions, but you write them in R.
Absolutely. Revolution, as part of a proprietary offering, they offer specific algorithms that they have already ported.
Hadoopinized, maybe. However you want to say.
Ported is incorrect because the sequence of steps is different, so it's a new algorithm. But the statistic is the same. So LM is LM. The algorithm is different, but the model is the same. So of course, that's a handful. It's not 5,000. So it will take years, if not decades, to convert the whole community and say, let's write for real stuff now. Let's stop writing for
in memory
laptop.
So let me ask you there something. Is it then hard for people that come out of the R community to kind of understand and get their head around of some of the limitations that Hadoop provides, right? Okay, this is map, this is shuffle, this is reduce, or is there any help that you provide there to some higher abstraction, or they just straight have to write their own partitioner, their own map function, their own reduce function, and it's just you write it in R instead of Java?
The first step was RMR2 was to help people do that, but on the other hand, it's not just like having, it's based on streaming underneath, right?
Okay.
And it's not just having streaming because we serialize every R object, transparently. So you put in a matrix as a key, it comes out the matrix on the other side. You could put a function as a key. I don't know why you would do that, but...
Let me make sure I understand this. So you said you serialize R objects, but then you said you use streaming. So you basically use Hadoop streaming to communicate between R and Java MapReduce code.
Yeah.
Is that,
yeah.
And then how do you do the serialization? You using streaming there as well, or you serialize the R straight into a byte stream, or how's that working?
It's I think it's a hybrid of the two things you said. So Hadoop streaming defines a binary format that they're willing to process. And so for simple data sets, data types, we just use that. And for the complicated one, we just say, okay, this is a bunch of row bytes, and underneath it's serialized using the internal R machinery. So that's why we can serialize like functions. Type bytes doesn't have a provision to serialize functions or closures or stuff like that. But we just say, okay, these are row bytes, don't bother, and so those go through that way.
So that would mean you could do like image analytics with R on Hadoop as well, right? Or are you limited to kind of string, integer, Boolean data types? No,
you can do everything. Absolutely, you could have the key be an ID and the value in a map call, and the value be some raster image format. That's what people have found it to be. Particular amenable. It's just complex data types and passive matrices around, particularly doing matrix computation. So you process medium-sized matrices, and then in the reducer you pull all them together and stuff like that.
So when we talked offline, you touched a little bit on performance. Well, is the whole streaming thing an issue, or is there anything inside with a better Java integration that might help you in the future, or is that not really a problem because R is usually doing complex CPU processing and I/O isn't a problem?
There's a price to pay when you use very small keys and values because especially if you're calling out to R serialization. So using specialized R types like a matrix or a function, but in very small sizes, that's kind of a sore point that we're trying to fix now. But that means we have to re-implement ourselves a little more of the serialization machinery. So we have people that are hitting some of these use cases that are not performing very well, and we're trying to fix those. For those that work well, there is a price to pay to use R anyway, and so if the network and disks are not incredibly performant, we can get really close to Java. I used a comparison as a guiding test case for a release, and we got like within 20% of Java. That's on EC2.
Right.
So
it's already slow anyhow, right?
It's so slow anyhow. Yeah. On my laptop, it's all SSDs and 4 CPU cores and 8 threads. We were like 5x slower than Java. The reality is somewhere in between.
It might be not even matter, right? Because you just add more hardware to the system. The whole idea is that it's linear scalable and it's it's
absolutely. But there's a point where if you use the interpreter the wrong way, you're going to have 100x slowdown. Yeah. And that not everybody can afford the hardware to counter that. Right? So we need to be in like 2x, 5x distance, and then the other advantages we're going to pay off. For instance, just if you're prototyping quickly, if you're doing one-off, if you're doing exploratory analysis, you don't want to do everything in Java. I can tell you, I've done that in the old times, and it's really...
And you write a class long like this for like 2 lines of code that really matter, right?
Which, talking of which, talking about the abstraction, we have a new package coming that's just released that's called Plier MR. Plier is one of the most downloaded packages for data manipulation in R. We took inspiration for that and a little bit from SQL to try to get something easier. So you don't select the key. You just say group by. It's the same thing. But people just can build onto their culture, group by understand this.
Exactly.
Instead of map, it's called select, or it's called transform.
Right.
And it has a slightly easier syntax.
And then people are like, oh yeah, I saw it before.
And if you see underline it, there's 2 lines of the other package. Create a key value pair. The key is the column, the group by. It's very simple. But we're trying to get another little step of abstraction. Again, it doesn't do the magic of translating algorithms. But it makes it more
easy.
accessible.
Well, and that's the most important thing, right? So, what are the exciting use cases you can share that people running on this platform?
Oh, wait a second.
Oh, okay.
And with new package PerMR, I can write the word count. Word count is I can write it in a tweet. It's 140 characters.
Nice.
But it's too slow, so I'm working on the speed. And as soon as the speed is all right, I will tweet that this is word count in 140 characters.
Oh, that's amazing. Yeah, I think that's where everybody's going, right? It's about really efficiency of engineering resources, right? That's why you have the Casa log and Scala and what have you, like all how readable, manageable, and short can you make code, right? Because in the end, writing code that compiles isn't the problem, right? The problem is to write code that human beings can maintain, read, and
over the life.
Yeah.
And I like that you say short. That's an opportunity for a little plug. I have a micro blog about restraint in programming, which is mostly conciseness. If you look at the actual citation, but in general, you decide not to use loops and do everything with functions.
Right. When
I was forced to use Perl in my whole biotech years, I refused to use for loops.
Yeah.
So my code had no for loops.
Okay.
And
what's the URL?
Aestheticprogrammer.info.
Okay. All right.
And I thought the aesthetic programmer should not drink beer, but and there's a citation of a Paul Graham blog where I think he says conciseness is power.
Yeah.
Essentially, we've been talking about what makes code elegant, what makes code reusable, what makes code easy to fix, and it's spinning around conciseness. If you reuse more, if you don't express yourself twice, if you don't have boilerplate code, it's all towards compression of ideas into their kind of essence. And then bugs are fewer, and all the other advantages seem to be correlated, at least, if not caused by conciseness. So I think, it's a good point.
I want to come back to the use cases, though.
Use cases,
like,
absolutely.
What are people like? What's the most amazing thing that people running on your platform that you're aware of or you can share?
Yeah, I know that it's in production in Fortune 100, at least 3 cases, but would they tell me what they do with it? But there's many verticals. I know banks. I know agriculture.
Most likely, like some predictive analytics or like scoring, fraud analytics. You think, or
it's modeling a complex phenomenon, like in agriculture. Trying to get the exact amount of water. I'm not saying plant by plant, but maybe square foot by square foot. At this point, where it's a kind of big data or data intensive agriculture, and
that's pretty impressive.
I used to joke, imagine one day when sensors are cheaper than corn, and we can just spray them. They're biodegradable. We can just spray on the field. And then I talked with somebody from Monsanto. I don't think we are very far from that. They can see a lot, and so they take the data into RHadoop and do stuff with it.
In any other use case? So aquaculture, to I guess then predict growth rates and I guess that's a big business, right? Financial services?
Yeah, the financial services is just they show me a little bit, but they don't tell me what the use case is. It's all secret, right? So
yeah. So do you is there like image processing?
Not yet. I want people to do it.
Yeah, I think it's very fascinating, right?
Yeah.
What you can do there.
Yeah, there's all the graphics devices in R write directly out to file systems, so there's some technical issues with
I see.
you need to grab the output. But yes, my idea is to do a big data visualization in R, where you can build something that's intrinsically not possible without that infrastructure of R and Hadoop.
Maybe doing a lot of tiles and partition by the tile or something.
What a video, one or two. Yeah.
And so what was switching topics a little bit, what was the most difficult to start an open source project in the Hadoop space? Is that getting the community on board? Is it getting the right ideas implemented? What did you see as a kind of the cultural, social challenge to build an open source project?
Well, R is great because it has a level where you can use it. It is interactive, like exploratory, where you basically don't need to be a programmer. Like it's really, short of a spreadsheet, really, it's the next best thing if you're really, starting from nothing. But there's multiple levels. You can write scripts and you can write modules and really do development like a real programming language. It's really full-featured. And so we have a 2 million user strong community of users, but those users are not ready to do a pull request. Those are users that most of them use it most interactively, and then there's another subset that can write decent scripts, and then the package developers, at least in the public sphere, is 100 to 200 people.
Wow.
So when you say it's 2 million people, don't imagine that's 2 million people doing pull requests on the project, right? It's So we really need to help them deploying. I think it's a hard part, deploying a non-Java piece of code on a Java infrastructure. It's kind of the hardest part for people when they're starting, and we need to do a lot of hand-holding and convincing that administrators that it's all right, that it's tried and true, that nothing bad is going to happen. And so I think that's being a C-based, Fortran-based software in the Java world is a little bit difficult, combined with the fact that users are not necessarily so technically sophisticated. Which is not saying that they're stupid. They're excellent statisticians, they're domain experts,
but they're not Java
They're just
developers.
not computer scientists.
What's a completely different audience?
Who could install the thing on 1,000 machines with a keystroke, right? But not everybody can do that. So.
Yeah, I mean, we see that quite a lot, right? Where there's just different audiences. Sometimes the perception of what is a data scientist is mixed, right? You have software developers, right? That they push into, now look into this support vector machine, whatever. And they're like, well, I'm writing Java software, right? And then you have people that are very strong on the mathematical side and say, well, why don't you develop a 1,000-node distributed computation platform? And like, I do other things, right? Interesting.
I think if you build it, say they will come. I guess there's lots of people interested in more direct access to data and make it easier. And if there is a tool that opens it up to another sector of people, you will make another bunch of people more productive and more and happier. And there's a limit. You can't make it more easier than some, and then whatever you have to do the best you can do.
So outside of RHadoop, what are other open source projects? Maybe as a final question, what are other open source projects you see that you're really excited about, or that you maybe consider to incorporate, or that you think have a great future?
I think JavaScript has a great future.
Yeah. Okay.
I think when I'm gonna date.
Did you look into Reno and those kind of platforms that run JavaScript server side? Do you know Reno? It's from the...
I looked into Node.
Okay, Node.js, yeah.
I think Reno is something I had on my to-do list, but I don't think I've had time to get to.
So we're using this actually to push some JavaScript code down back to the server. It's kind of similar to what Node.js and those kind of things do. But yeah, so we basically run D3 visualization on the server side with Reno. And Reno is basically Mozilla, I think a Mozilla project. And
if you look at the trajectory, Java started on appliances. Before it was a language for applets, and then I don't know why they moved it. They needed a language for applets at Sun, It became a language for applets. It completely, totally bombed there. It failed drastic. I don't think I've seen an applet in 5 years or something. But then it became a server side, and now there's all the Hadoop thing is based on Java. I think JavaScript is following a similar trajectory. Of course, I don't have the crystal ball, but the tools are getting better.
But you have R.
I can try to model it over 2 examples. So we'll see. It's already moving on the server side. It has interesting tools. It has a lot of people working on an interpreter so that you can write crappy code and it's going to run fast anyway.
Yeah.
And so I think
there's a lot of investment put into JavaScript optimization by companies like Google and Apple.
I think some of the brightest minds in languages these days are employed in one of those 3 groups that are doing JavaScript. And there's companies like Meta Markets that are based on JavaScript. They're upfront about it. We run JavaScript on server and client side because it's simpler.
Yeah, that makes sense.
Fast enough for us.
Yeah. Well, thank you for stopping by. Cheers.
Thanks for having me.
And go and check out RHadoop and get your R code running on Hadoop.
Thank you.
Cheers.